let's talk a little bit about what this idea is, and then we'll dive in and we'll look at a number of examples, and then we will look at some uses of it as well. The best time to ask questions or make any comments is anytime you have a question or a comment, so please don't hesitate. Raise your hand, start speaking. I'll be very happy to listen to what you have to say. Let's talk about the problem first, and then let's talk about a few solutions, and then we'll talk about how sealed classes actually help with that. Well, when it comes to object-oriented programming, well, sealed classes were introduced in Java very recently, and you may wonder, because object-oriented programming has been around for a very long time. In fact, object-oriented programming was introduced back in 1967. In 1967, Dahl and Nygaard, two Norwegians, introduced this idea of object-oriented programming. So you may wonder, wait a minute, more than 50 plus years later, why would we want to make any changes? Shouldn't we all be done with this if it's been around that long, right? So that's a fair question to ask. Well, as it turns out, when we start doing things, we learn from doing things. And when we start learning from doing things, we have a new set of problems, and we often try to find answers to solving those problems. And one such problem is this area that is addressed by the sealed classes. We all know about what abstract classes are. An abstract class is a class which cannot have any instances directly. So typically you create an abstract class to define an abstraction, and you are saying that, hey, this represents some common ideas, common implementation that might be shared by a number of other implementations. For example, you may say animal is abstract, whereas you have specific types of animals, maybe a cat or a dog, or you say a human is abstract, but you may have different types or categories of humans and so on. So abstract classes are meant to have zero instances, and we know that. Now, final classes, as we also know, are classes that you can create as many instances as you want to, but you cannot extend from final classes. So there is these opposite ends, if you will. An abstract class is useful as a base for any number of classes. A final class cannot be a base for any class. So one is intended to inherit, the other is intended not to inherit, and so these two are the extremes. Now, while that is really great, there are times when we want something a little bit in between. And what we mean by in between is, I want to have a class or an interface from which I want to inherit, but I want to restrict who can inherit from it and who cannot inherit from it. So this is where we probably want to restrict the hierarchy. Now, the very first question is, why would you want to do that? You know, why would you want to restrict who can inherit and who cannot inherit? Let's take an example for it, because if we don't understand a use case, why bother solving a problem? So let's imagine for a minute you are creating an application where you have a lot of classes and interfaces in your application. But when you deploy your application, let's say the clients who are using your application, it's not like a web application where somebody visits a website and uses it. It's not like an application where you just distribute it and anybody in the world can use it. Imagine this application is very targeted to some of your clients. You may have banks that use your application. You may have maybe hotels that use your application and so on. Or you may have a chemical industry that is using your application. In each of these deployments, the product is supposed to provide a core set of logic, but it allows them to extend a few things by writing plugins. Now, this is often referred to as a plugin architecture. One of the most famous plugin architectures, as you know, is the Eclipse. And Eclipse is a very, very powerful plugin architecture, but so is Jenkins, PMD, and so on, are different tools that allow you this plugin architecture. Now, let's imagine you created this application and you have provided that to maybe my company. and I am writing a plugin that I can, implement. I'm going to do some testing with my plugin as a good citizen. I integrate my plugin with your application. So when you fire up your application, it says, hey, get me all the implementations of a certain interface, and ta-da, you are able to get access to my class, and you're able to use that in your application. That's how a plugin architecture actually works. Except, all of a sudden, we realize one problem. In your application, let's say you have several classes and interfaces, and I can implement your classes and interfaces, but then you say, oh, but wait a minute, these interfaces are for you to use, but you shouldn't be implementing these interfaces. These interfaces are for the company that is writing the product to implement, but the plugins are supposed to use these interfaces or classes, but they're not supposed to implement or extend those classes. And why? Because those may be domain-specific classes that you have implemented, and it doesn't make sense for others to implement those domain-specific classes. It only makes sense for them to use it. So the problem at hand is, you now have a set of classes and interfaces others can use and others can extend, but you also have a set of interfaces and classes others can only use, but they're not supposed to extend from it. And how do you restrict that is a problem. I actually have clients who have these problems. And when I talk to them about how they implement it, it's horrific to find out what they are doing to implement, because every one of them have their own way of doing it, and then it can become really hard. And remember, the more code you write, the more code you have to maintain. And the more code you have to maintain, the more expensive it becomes over time. So if anything that can be done for you, rather than you having to implement, it becomes a lot more easier to work with. So that is the why part of we need some restrictions, is that within a domain, you want to restrict what you can do. For example, right, let's take a little bit more concrete example to understand it. Let's say I have a deck of cards. Well, if you define a deck of cards, you probably have an abstract class that defines a card, but you have maybe the diamonds and the spades and the clubs and so on. And as a person using this application, I can create an object of a card. I can use an object of a card. But I decide I'm going to invent a Venkat's, card. And you're going to say, sorry, you shouldn't be doing that. Because we have very well clearly defined what a deck of cards should be. And when you play the cards with anybody, these are the 4 types we're going to be expecting, and the 4 different colors, or whatever the number of configurations, 2 colors. So basically, you're going to say, you don't want to make up your own stuff like that, right? So essentially, you're going to use them, but don't cook up your own stuff in your application. How do you restrict that is the question. So we saw the why, but the question is, how can we do this? So when a problem is presented towards us, what do we normally do? As creative people, we tend to come up with creative solutions. And the more creative we get, the more suffering that inflicts on us later on, because you do something and then you realize, gosh, that gave us a loophole. How do you fix it? And then we put a little bit more code to fix that loophole. And then 10 weeks later, somebody says, what about this? And I have a name for that. It's called the Scotch tape driven development. You keep putting a little Scotch tape on it. And then you look at this, and there's this growth of Scotch tape on it, and it's kind of wobbly. And you're like, how do I maintain this code, right? And then you inherit that code. And when you join the project, you're always surprised by all these Scotch tapes peeling off, and you put more Scotch tape on it for your share, and that becomes really hard to maintain the code. Let's talk about some ways to actually implement this. So I'm going to talk about one solution, but before we do, let's start with some initial code to understand the problem. So I have a class here called a power. So my class is called power. And as you can imagine, this power represents an abstraction of a power. So as you would expect, I have an AC power, where the AC power extends from power, and I have a DC power that extends from power as well. As a user of these, I can say, hey, I want to use a power, and you can get the power and you can just print it out right there. So I can call the use and send a AC, I can call use and send DC. So very simple example, right? So a power is a base class, AC and DC are two derived classes. You may say, oh Venkat, you should have marked power as abstract. Sure, I can. What does that do? It simply restricts me from creating an object of power. That's all, not a big deal. However, what if I create my power? And my power extends power. But you say, I don't want you to be creating your own power. We give you AC power, we give you DC power. You can use the power given to you, but you shouldn't go off and create your own power. That's not allowed in this application. How do you restrict me from doing that? So in this case, if I were to just compile it and run the code, it does not give us any error, obviously, because nothing stops us from creating those power. So that is basically the implementation in this code. So what is our objective in this particular example? That's the question we want to talk right now. So the objective here really is we want to be sure that we don't go off to create our own implementation of the power. That's what we are really trying to do. So that's the real objective in terms of what we are trying to do. So now you have a problem on your hand, right? So imagine you're the programmer who has been given this particular requirement to implement, and your requirement that day is to scratch your head until you find a way to limit this from being created. So how creative are you going to get in order for you to be able to support it is the question. So let's think of an answer. This is what I call as a solution one. Now, in general though, you can call them as solution one. Alternatively, you can call them as hacks. We come up with these little hacks that we do oftentimes, and those hacks become really hard to maintain. What is another problem with hacks? Another problem with hack is when you hire a person on your team, you got to educate them on your little hack. So they look at this code and they're scratching their head and saying, what's going on in this case? And somebody says, let us explain this to you, why we are doing this and how we are accomplishing it. So now they have to learn your little hack and they have to follow it. That's more expensive again, because when somebody comes on board, they got to learn your way of doing things. And when you go to another project, you got to learn about their way of doing things, and there's no consistency. This actually makes it even more entertaining, because they say, well, in the company I worked in, we solved this problem differently. Now we are debating about 3 different ways to solve the same problem, right? So that is what is going to lead to that. But let's look at one hack, one solution, how we can implement this. So notice in this particular case, my power is sitting right there as it did before, nothing really different, but I have a final class called AC. Why did I mark it final? Because I don't want anyone to inherit from AC. Because if they inherit from AC, now again, it's like, gosh, you shouldn't be extending from it. That's an easier problem to solve, right? Just mark it final. If you make an AC final, they cannot implement that particular class, extend that class, so that's awesome. Likewise, we will make the DC final as well. So, yay, did we solve the problem? Not really. You cannot extend from AC, you cannot extend from DC, but what about the base class power? Somebody can still create my power from the base class and then walk away, isn't it? So you want to be able to restrict that. So in this case, what if we don't want anyone to inherit from my power? What are we going to do to it? Well, the answer to that question really is, you're thinking, maybe there is a way for me to solve that particular problem in here. So what if I were to think about this with a little bit more creative solution here and rethink about this? So the answer to that question really in this particular case is, I'm going to pull this up again here to take a look at it. So in this case, I'm going to pull up the power again and take a look at this one more time. And I can say, hey, maybe I will not make power as a public class. If I don't make it public, what happens? Well, it becomes package friendly. If it becomes package friendly, you cannot extend from power from the outside because you don't have access to my package. And so as a result, I can say you cannot extend from power. Well, AC and DC are final, so you cannot extend from them too. So that's cool, isn't it? Well, yes, until you realize that it's legitimate for others to use power as a base. You just don't want them to inherit from it. You're like, oops, that wouldn't work after all. Because if you make it package private, others cannot even see it. So you don't want to tell them, don't use it. You just want to tell them, don't extend from it. Well, you don't have that capability. So by making it package friendly, you shut it out and made it invisible for them, and they cannot even use it. And if this was an interface, they're like, how do we use a common interface? We can use AC, we can use DC, but if we want to abstract and use it as a base power, we cannot write the code to at a base class level or an interface. That's not going to make a happy user in this case. So even though the thought of making that package friendly is a great idea, that kind of falls short very quickly, isn't it? So in this case, of course, the use power, we are able to use the power. And again, this doesn't give us any error. So that is a bit of a failed attempt in this particular case. After all, if you notice it, that didn't take us too far into what we wanted to do, right? So that's really not helping us a great deal. So what can we do? So we want to think about maybe some solutions. So let's think of one other solution here that we could think about. So this is my solution one I'm going to propose in terms of what we can do in this particular case. So let's rethink about the problem. How can I really make this work so that my users of the code can use an abstraction, but they are not able to inherit from it or extend from it? How can I accomplish that? So let's give it a try one more time. So let's go back here and pull up a solution one and take a look at it and see maybe there's a way to solve this problem. So here is again my power that is sitting there, my AC power and then my DC power. And again, like the solution we saw. So no compilation error though, but guess what we can do? In the use power, I am going to say, aha, I got an idea for you. Power is public, so anybody can see it. But in my code, on my part of the system, remember, there's a core and there's a plugin. And the plugin creates objects, and my code is using the object. And I have a gate, and in the gate I say, hey, use the power. If the power is an instance of AC, or a power is an instance of DC, then use it. If it's not one of the two, I'm going to throw an exception. Sorry, derived instance of this type is not allowed. So what's the good news and what's the bad news? Good news, you can tell people you shouldn't be inheriting from my power. You shouldn't have your own extensions. You can use AC or DC, but if you use any other type that you created, we're going to give you an error. Good news, you're restricting them. Bad news, you have to check for every type that's available. Now the programmer says, that's not a problem. I will create an array of this type. And somebody says, is it an array or is it a list? And somebody says, it is a set or a list. So we're debating about how to implement this code now, because we need to check against one of several types after all. In the meantime, the developers of your system's plugin, what did they do? They took the time to create their own type of power. And then they compiled the code and they ran the code, and at runtime, it blows up with an exception. How do you feel if that happened to you? You're going to be pretty upset, isn't it? You're going to say, darn it, if that is the case, why didn't you tell me before? I wouldn't have wasted my time writing it. And your answer is, why didn't you read the documentation? And that never makes friends after that, right? So that was not an elegant solution. It is fail at runtime is not as good as get an error during compile time. So if you can see that error when you compile the code. So when I say, class my power extends power, and the compiler says, sorry, you cannot inherit from this class. Hey, that's actually good. It doesn't allow me to extend, but I can use it, is a better feedback than saying, yeah, go ahead and extend it, and we will complain during runtime. And that's not really a friendly code, not a friendly implementation. So that's not a very nice implementation. As you can see, this is, I will allow you to compile, but I will fail at runtime, right? So, and so that check can be really hard. It's error prone and it's hard to maintain. But it's even worse, everywhere you use this object, now you got to keep checking. Is that a valid type to use? Because if you have some code where you just receive a power object and call it, and it was not the type you expected, you're like, darn it, how did that error happen? Now you got to start tightening everywhere you use this object. Not a very pleasant experience, right? So what can we do to minimize that? So that hack did not really go really well. Let's think of yet another solution for that particular problem. Maybe there is a better way to do this. So here is, again, you have the DC, which extends from power, as you can see. You have the class power, but you have an AC that extends from power as well. But guess what we did? I mean, I love this idea of cleverness of programmers, right? You tell programmers, go find an answer, and you just look at how many different ways people can hack their way through, right? So here is another interesting solution. You say, aha, but I'm going to keep the power as public because they need to use it, but I'm going to make the constructor really package friendly. So what happens if the constructor is package friendly? You can only call the constructor from a code within the same package. So from AC, you can call the constructor of power. From DC, you can call the constructor of power, but others cannot write a class and call the base constructor because that constructor is not visible. So now this, again, the question you want to ask is, how does that feel? It might feel great for a moment, and then you're kind of like wondering, is that a feature or a flaw? Is that something you would proudly show to somebody, or would you be very defiant to say, I kind of solved it, but I'm not sure if this is a good one, but I want to show it to you. And you're just not really sure because you're not sure if they will praise you for doing it or they will condemn you for doing it, right? That's the borderline. We are not sure whether this is something we want to be proud about, right? And so that's kind of the solution here is it feels hacky, right? Again, that doesn't seem like it's a great idea. So when somebody writes a class, they get an error saying, sorry, the base constructor is not available. It's package friendly. Now, somebody says, ooh, so I get it. So if I need to access your power class, I'm going to make my class the same package as your class. And now you're sitting there scratching your head, darn it, what do I do about it? Well, there are two answers to this. If you're programming before Java 9, or if you're programming in any version of Java, but if you're not using modules, guess what? Somebody can create a class with the same package as your class. I'm not saying that is, the correct way to do. But if somebody is desperate, what do? You cannot stop them, right? So they create a class in the same package as your class, even though it's their code. And now you're telling them, you shouldn't be doing this. But that's too late because they got around it. So this is no guarantee. If you're using Java modules, then they will get an error saying, hey, the same package cannot exist on two different modules, but that requires you to use modules to stop them, but otherwise you won't have that feature. How do you solve that particular problem? So again, the point is that definitely feels hacky than it should be. So the good news is this is error at compile time. Why is it an error at compile time? Because a constructor is package friendly. Pardon me, I'm not part of the same package, so I won't be able to compile it. So the good news is this is better than before. We have a compilation error, but we still create a class in the same package in the version below. So that's another thing. If I'm a developer and in your own team, and you said there's going to be only two classes, and I end up creating a third class in the same package. And now you got to come down to me and say, no, you shouldn't create this class. Even though you're part of our team, you're not supposed to create that class because it was intended from the domain point of view to have only 2 implementation. Why in the world you created a third one? Again, you cannot restrict me from doing it. So this turns out to be really a hack after all. So the answer is that did not go really well. Now, when you tell this to developers, what do they tell you? But they say, I've got another idea, right? And that another idea is, one of my clients has actually done this. They created their own set of annotations. And every class that inherits from their interface will have an annotation on top of it. And then guess what they did? They spent the time writing their own annotation processor. So when the compiler compiles through the code, their annotation processor kicks in, looks for the annotation, and if the annotation is there, it allows that particular class. If it's not there, it denies it. Now imagine the complexity of doing so. I spoke to the developer that wrote that annotation processor. He declined to talk to me that day, right? Because he was still in pain and didn't want to ever discuss that any further. So that can be a lot of work to do. And you only wish you don't get asked to maintain that code, right? Because that's a lot of code to maintain for very little benefit than simply saying, hey, you shouldn't really use it. Again, it's error prone, hard to maintain, not very desirable. So what can we do? So we definitely want to rethink about a solution, enter sealed classes. Now this term is called sealed classes. Now take the word classes a little lightly, if you will. So when you hear the word sealed, think of it as a sealed thingy. It's a sealed class, sealed interface. It could be sealed, either one of them. They call it sealed classes. It doesn't mean sealed classes. It's a sealed thingy. So it could be a sealed class, could be a sealed interface, what have you. So what is this concept of sealed classes? When you write an interface, you can define that as sealed. And when you say it is sealed, you are closing an hierarchy that can only have those in the hierarchy. So I'm going to give you a little example just to get a feel for it. And then I'll come back to the example we've been working with after that. So notice right here, I'm going to say output new red light. So I'm going to create a red light object right there, right? New red light. That's all I'm saying, a new red light. In fact, let's even do this. I'll say traffic light. Traffic light will say light is equal to new red light. And I'm going to then simply display the light right here. So we got something called a traffic light, and then I'm going to create a red light, and I'm going to display that information. So I'm going to create right here traffic light.java, and here I say a public, let's say a public interface, we'll call it a traffic light, and then I'm going to say a public final class. Well, because in the same file, I'll simply say final class, and I'll call this as red light implements, in this case, implements. Let's call this as traffic light. And likewise, as you would imagine, I also have a yellow light, and I also have what is called a green light as well. So I got these 3 things in here that I've defined, so nothing really exciting so far, right? So I go back to the class, I run the code, and it just worked, not a problem. But I come along and say a class, a broken light, which implements the traffic light right there. And guess what? It doesn't stop me from implementing it. There was no error. But I don't want that to happen, right? That's what I want to stop. So I go back to my traffic light and say a public sealed interface. So I use the word sealed to say that interface is now a closed hierarchy. And that interface can have only 3 classes implementing from it. And those are the red light, the yellow light, and the green light. So we sealed that interface right there. What is the consequence of doing this? The consequence of doing this is, if I go back to the code and try to compile it, I got an error. I'll read that for you because the font is small. It says class is not allowed to extend sealed class traffic light. You and I know it's not a class, it's an interface, right? So when they say sealed class, take that with a grain of salt. It's a sealed interface. So it says the class is not allowed to extend the sealed class traffic light is not listed in the permits clause. That's what it says. So notice how we closed that hierarchy. We didn't have to be clever in solving this problem. You simply mark it as sealed and you are done. So others can use the traffic light. You saw that within the main, I'm using the traffic light, but I cannot extend, I cannot implement from a sealed interface. So that closes the hierarchy. Now the question is, how does it know what hierarchy to close is the question. And this is the default behavior, if you will. So if you go back to the traffic light, notice all the classes are in the same file. I know that's not practical most of the time, but that is the default in terms of how it works. So if all the classes are on the same file and you mark your class or interface as sealed, then that closes the hierarchy for you. That is the first step in solving this problem. So can we agree that that's a much cleaner solution, right? You don't have to be creating your own hacks. It becomes a lot easier to work with. And also there is another benefit, and that is the code conveys the intent. I'm a big fan of that. When you look at a code, you're like, oh, I understand what you're doing. In the earlier cases, you have my constructor not as public, and I'm looking at with suspicion. Why did you make the constructor not public? I got to go to your team and say, hey, excuse me, the constructor is not public. Why is that? And they's like, sit down, let me tell you the story about it, right? But why do you want to hear your stories? I just want to know what the intent is. Make that clear. And even worse, somebody writes a comment on that line, // this is not public. And they leave it with that. They don't tell you why, because that would be too easy to know, right? And you're scratching your head, why is this comment there right now? So that's not really a great idea, whereas this becomes really more explicit in terms of what we did right there. Now, of course, you say, yeah, that's great, but I do want to create a flashing light like that, because there are times when you do have flashing lights. So how do I support a flashing light? Notice that's an error, but I want that to be possible. How can I do it? So now you can go back to traffic light and say, hey, the sealed interface traffic light, over here you say permits. And after permits, you say, because it's a little longer, I'll put it on the next line. You can say permits red light, yellow light, a green light, and flashing light. And you can specify those that are permitted. So this is the non-default approach. So this is why when it said permits list, it was using a default a few minutes ago. So the permits list basically says, oh, your traffic light interface can have 4 children, the red light, yellow light, and green light, which incidentally are in the same file, but you can move them to another file if you wanted to. Nothing stops you from doing it. And flashing light, which is not in this file, it's in another file. Just a quick note, if you're not using Java modules, then that particular class that is the child of your sealed interface or class is required to be in the same package. So if you're not using Java modules, they all should be in the same package. They can be in different files, but they should be in the same package. That's a requirement. If you're using Java modules, they can be in any package, but they are required to be in the same module. So that's a bit more secure in that regard. Another good reason to start using modules if you're not using modules already. So with that said, we have a basic understanding of this. So it's time for us to, let's make sure it's actually working, right? So I run the code now. And what does it say? Well, make that final for now. We'll understand why that is in a few minutes. And notice the code is actually working right there. So that's an example of how that is actually working. So we created a sealed class. You have a hierarchy, and you want to be able to, create a non-permitted class, and how that actually is working. We're able to see that in here. So let's come back and take a look at this under the hood in just a minute and see how that works. But that's basically how that is actually being implemented. But if you're really curious about it, and I think we should be, let's go ahead and create a bin directory and say javac -d bin star.java, and now let's say javap and I have all these aliases for looking into it, and I'm going to take a look at the traffic light over here. Oh, actually, you know what, let me just expand it. So I'm going to say which javac, and let's take a look at that javac right there. So I'm going to say javac -c -p -v and bin traffic light. Let's just pull it up right there and take a look at it. So what does this show us? Oops, pardon me. So let's take a look at it and see what it tells us right there in terms of what it's going to show. And in this case, of course, I want to say this is the javap, right? Thank you. So I want to see javap and -c -v -p, and let's say bin traffic light and take a look at it. And oh, I think that already gave us that. Did you notice in the bytecode, it tells you permitted subclasses, right? That is part of the bytecode. It keeps that information in the bytecode and says the permitted classes are those list of classes. Yes, please.
Maybe I'm guessing that, but the question is coming to my mind that how is it different from enum?
Oh, beautiful, beautiful. You nailed it. I love it. Enums are an example of sealed hierarchy, but I don't want to create an enum. I want to create my own hierarchy. So what you just said is, I want to do what is available for enum, but for a general purpose class. I love it. Beautiful, right? You couldn't have said it. I couldn't have said it better. So that's great to have you on board with that idea, right? That's exactly right. You nailed it. Your enums are a sealed hierarchy, and that's exactly what you did. You said you can have another member, right? You're restricted to this, except this could be for your own abstractions, not restricted to enums, right? If you tell me write an enum to do it, guess what? That enum becomes really bulky, right? And you cannot really have that in different classes in your system. Where it gets a little bit more tricky, you say, all right, Venkat, that's all great, but for testing purposes, I need to create a mock object. Ooh, how do I do that with enums? Now you know why the enums are not good enough, right? So the idea starts there, and you nailed it. But you want something that's a lot more powerful to extend that idea further. Love that question. Great. So that's exactly what we are doing here, is that permits clause and how we brought that together. Love it. So we looked at how that is under the hood. Now let's talk about how this is going to look like in the example that we are seeing. So what I want to show you here is a little example of creating a sealed class and how that's going to look like. So let's go back to our example. Notice what I did here to the example we've been working with, right? So I have a public sealed class power, and then I say final AC and final DC extending from power. Why do I need to say final? Because I closed my hierarchy. So I have power right up there, and I got AC, which is one child. I got DC, which is another child. You are not allowed to extend from the parent. You shouldn't extend from the children either. Because if you can extend from the children, we lost the game, isn't it? So you want to make sure that's a closed hierarchy. So your leaves are final and your root is sealed. Am I making sense so far? So seal the root and make the leaf final. So that way you cannot extend the hierarchy from anywhere. So that is the one approach to how you can actually take that and close that hierarchy as you define it, so that gives you that power to work with that. So by default, the derived classes of the sealed class reside in the same file. That's just the default. The number of times I would use the default comes close to 0, right? It's very impractical. Why? Because you know that if multiple classes are on the same file, those classes cannot be public. If they're not public, others cannot use it. So the practicality of this is very limited. But that is the default. That's a good starting point as you're evolving code before you go further. So good news, it's easy to start using it. Bad news, if the classes are large, the file becomes hard to maintain. But that's not only the problem, they're not visible outside as well. So the practicality is very limited. So the good news is if you try to extend from my power, you'll get an error. We saw the example of that earlier, how you will get that error. So so that's a better design already, isn't it? So we can be happy about it. Now let's talk about creating an interface with permits. So in this example, what I'm going to show you is creating an interface with permits. So let's go ahead and say in here is my sealed power, in this case, which is a sealed class. And well, you can make it as an interface in this case, AC and DC. That's what you want to create. And you want to be able to restrict what it is and how you can use it. So that's basically what your idea here is, to bring that in. So that's example I showed you a few minutes ago. So let's take a look at this. I have a traffic light, which is an interface, and I permit, the red, green, yellow. I call it a blinking light right here rather than a flashing light. Now the final class blinking light implements the traffic light. So if we don't use permit, all the derived stuff are in the same file. But if you use permits, then you need to list everything, right? So you may say, hey, if I have a few classes in the same file, can I just use permits to only tell what's from the outside? No. Either you don't use permits or you put everything in the permits. Now, somebody asked me the other day, what if I have 20 classes that I have to list? Do I have to list all of them? My recommendation is find help, right? Because if you're creating 20 classes, where are the adults in the room? Something is going wrong here, right? So that's not a good design, most likely. So go find some help and see what's going on. So that's what I would recommend, is that yes, you have to list all of them if you do have to list them. So either don't list any or list all of them. It's all or nothing in this case. So that's basically how you define that permits clause. Now, for creating the classes outside of the package, what's going to happen? So this is the light package, as you can see. Now in the user package, I cannot create any classes, but this is also in light, this is also in light, and the red light is also in light, but it could have been in another package. Not really. If you don't use modules, it cannot be in a different package. That's a requirement, right? So all of them are required to be in the same package. If you're not using modules, that's a requirement. Okay, so that's good so far. And if we stop this right now, we can live with an impression, okay, this is great, it's fairly simple, we can work with it. Please.
So, because we don't want others to extend the time. Like, I want to understand. Can't we make it also see like?
If you make it sealed, remember what sealed means. Sealed means I'm going to restrict who my children are. So I make AC as sealed. Your question is, who are the children of AC? Then why would you make it sealed? What does sealed mean? I'm a base, I'm the root, and I want to tell you who the valid children are. So sealed requires children. If you don't have children, you cannot put sealed, right? Because again, what does sealed mean? I'm a base, and I'm going to tell you who my children are. And if you say this has no children, well, then you cannot put sealed on it, right? Because you don't have a hierarchy to define at that point. That's why the leaf are final and the root is sealed. Yeah, good, but good. We keep asking those questions, right? That's how we learn. That's how we think about it. Yes, please. Yes. So in AC you're saying, I'm sorry, in red light you're saying. Yeah, absolutely. So you're saying, this is my hierarchy,
Yeah.
but I want this hierarchy to extend further.
Exactly.
Yeah, absolutely. Then you make that sealed.
What if the root is sealed then? What if this traffic light is sealed?
So this root is sealed.
Yeah.
That also is a parent of another child.
Exactly.
Sealed, final, sealed.
Okay.
And then final.
Okay, understood.
So the leaf are final and the roots are sealed.
Okay.
Right? So that's how you extend your hierarchy.
That's
Yeah. So in this case, my red light is final, which implements traffic light, and I have the traffic light which is sealed, but it contains those classes, and the blinking light is final as well. And then of course in this case we can see that you have a smart light. But did you notice the smart light is in a different package in this case, right? It's in a completely different package, and that implements the traffic light, and that is allowed if you are using modules. As long as all the packages are in the same module, you're allowed to use that. If you want to move forward, that's perfectly fine. Okay, so far so good. Now, if we stop this right now, you can leave the room sane. So I'll pause for 10 seconds and give you the option to leave the room. No, you chose to stay here. So it's your own consequence. So now we're going to turn up the heat a little bit more. So wear your seat belts. It's going to get a little bumpy and turbulent, right? So now we are saying, when it comes to this hierarchy, we talked about this in same package. So when you are defining a class, you can make it final. That makes sense, isn't it? Because you're saying, here's my root, this is inheriting from the root, but this one is final, meaning nobody can extend from this class, so final. Final makes sense. Would you agree? And final is what you will use 99% of the time. So if you're creating a sealed, you'll make this final. If you don't put anything, you'll get a compilation error. It says, look, you are extending a sealed, you're leaving this open, not allowed, right? You'll get a compilation error. So final, don't even think about it. Put final. If you're not sure, put final. If you're not sure what to do, put final, right? And most of the time, that's what you want to use. Now, so we understand what final is. But then, you may say it is itself sealed. Why would you say the one below is sealed? I think your question kind of led us to that, right? Because you want to extend the hierarchy even further. So what you may do here is, you might do something like this, right? So you may say, I have a situation where I have, let's say, A right there, which is sealed, right? You have a B which extends A, and guess what? That is final. That would make sense. This is most used, right? Most used option. This is what would make really good sense. So you would make that final. But I say C extends A, but I say sealed. Why would we do that? So we can extend C with final D and final E. Would that make sense? So you can say, hey, I've got A which is sealed, B is the leaf, but C is not the leaf, it's just a node, and the node is going to have a child which is a B and a E. So your hierarchy is A, B and C itself is a parent of D and E. So far so good, isn't it? I'll give you option one more time to leave the room right now if you want to. Okay, you chose to stay, so don't blame me. Or what you can do is mark it non-sealed. Yeah. You are like, what? You are saying, notice how you designed this and you closed all of that? I'm going to open it. So if you think about it, you say, I don't understand that. Why would you do that? Because the minute you make it unsealed, non-sealed, what happens? You can inherit from that. Now you can just open up the hierarchy. And the minute you do it, you cannot tell me it is closed. Because if I ask you, hey, that base interface or class you saw, what are all the possible children? What's the honest answer? I don't know. And then you're like, all this for nothing. The first question is, why? The second question, more important, is, how? How do you use this? So you got to come up with a reasoning for it, right? How would you use this? That's a question we want to ask. So we'll answer that question now, with this. So what I want to show you here in this case is a situation where we have a final red light, nothing really exciting. You have a smart light that we are using right there, and blinking light, and you have a red light that we are using there, so nothing really exciting. Smart light again, so yellow light, I think the example that we saw earlier. And then of course the module, because you need to have module if you want this in different package, so we talked about that earlier, right? So nothing really exciting, so that's good so far. But what I want to show you here is that you want to be able to mark this as non-sealed. Let's take a look at this and see what that really means. So let's go up, fire this up and take a look at it. So notice the red light is final, we're good. We have a final blinking light, that's good. We got, in this case, a smart light which is final also, a blinking light which is final, and a sealed yellow light. So all that makes good sense. And the green light, so notice the green light is non-sealed. Now, wait a minute, why is green light not sealed, right? That's a question you may ask. So the green light, you have a class blinking green light extends green light. This is a terrible idea, isn't it? Because the minute you do this, anybody can keep inherit from green light and you cannot stop it, right? So the question is why, and the question is how. The first is don't do that, because that is not a good solution. So let's understand what you would do and why you would do this. Let's try to reason with this and see where this would actually make sense. So my argument here is that when you are defining a non-sealed, let's imagine this for a minute, if you will. So you are working on a team and you defined different lights. So you have a traffic light, you have a red light, you have a green light, you have a yellow light, and you're like, imagine you're working for the public works department, you're installing these lights, and somebody said, I need a blinking light as well, right? And your blinking light or flashing light is going to also be a good light to implement, and maybe your flashing light extends from red light, everything's great. Then somebody comes to you and says, hey, we have a problem. We are researching a new type of light. And this light is going to be unconventional. It's going to be for the modern times, but we don't know what that is. So we need to be able to experiment a light. You say, okay, can I call that an experimental light? They say, no. We got different projects running right now. We have one group researching one type of light, another group researching another type of light, a third group researching another third group of light. We don't know which one will even succeed because they are in the prototype phases. So what we want is really an ability to create our own lights that are experimental. And you say, okay, you still don't want anybody in the world to create their own lights, but you want people in your own team to be able to create your lights. So guess what you can do? And my recommendation is to follow this approach. So what I would do here is, in this case, this would be public as you can imagine. This would be public. This would be public as well, right? So far so good. But then I would say a package private, meaning don't put public, don't put private, don't put protected, right? You can put most of those, but make it package private. And then call it experimental extends A. And in this case, you will mark this as non-sealed. So what's going to happen now? Your experimental is in a package private. So that means in your package, imagine you're part of the module system, your package contains experimental, but that opens up as non-sealed from A. So nobody can extend from A. Nobody can extend from B. Nobody can extend from C because that is sealed. Nobody can extend from D and E because those two are final. But who can extend from experimental? Only the code in the same package. So the entire world cannot still abuse this feature, isn't it? So my recommendation is, if you're going to use non-sealed, make it a package private. So it can be opened up only for your code, not for everyone to use it. So this would be a nice way for you to allow a group of objects. This could also be used for mocking purposes and stubbing purposes if you want to create something for that purpose. So that's where non-sealed makes sense. So now, in the same package, right? In the same package, a package as experimental, you can create some experimental, if you will, experimental implementations, right? So in this case, implementations. So if you are making something as non-sealed, think about it several times over. So treat that as an exception than a norm. And if you really think about it, it actually makes sense now, because if you completely close it, that actually becomes a problem eventually, because there are times when you still want to open it for your own purpose. So by keeping it as a package private, you get the best of both worlds. It's closed for the world, but not closed for you in a restrictive manner. So that becomes the power of this. Please.
Non-sealed schemas, like in class without a modifier.
No, not at all. Non-sealed is still extending from a sealed.
Okay.
Right? You cannot just say non-sealed on any class.
No, that's what, like, if I don't say non-sealed over here,
Yeah.
would the behavior still be the same?
You'll get a compilation error. It's got to be one of the three: final, sealed, non-sealed. But you cannot put non-sealed on any class. It's only in this hierarchy, right? So the most option is final. Occasionally sealed, very rarely non-sealed. Yeah. Oh yes, this is why you need code reviews. Yeah, you cannot let people say do whatever you want to do. So if somebody says sneaky, sneaky, I went and put my class in there, you take them out to the parking lot and talk to them, right? And then they will know not to do that. Yeah. So but the beauty is that's in your control, right? It's not somebody else outside your package who's messing with that. Please.
Yeah, I had a question. So this is a suggestion which you're giving to have it in a private package, right? So just trying to understand why Java gave this feature to even have an option of public as well, right?
Yeah.
Non-sealed public as well.
Right.
What would be the case?
Yeah, so the reasoning is, you and I, right, I say this with respect, you and I we have this luxury of sitting and saying, you should have done it this way. But a language, when you make a change to it, the compilers can become extremely complex. And then we complain the compilation is very slow, right? So you're affecting the grammars a lot. So sometimes it's better to leave things to convention, because if you really think about it, this is such a rare option. If you break this whole thing, that's your problem, not their problem. So it's like any tool, right? You're saying, hey, they sold a hammer, but why didn't they restrict me from using the hammer to take the fly out of the forehead of a friend? That's your friend's choice to be your friend, not the person who sells the hammer, right? So that's kind of where the restriction is. Super, I love it. Good, great group. So I got 2 more minutes. I want to talk about a few more things. You can use a few metadata. You can call eSealed and find out if it is sealed or not. So they extended the reflection API, the meta classes, to find it. You can ask for get permitted subclasses, and that will tell you all the subclasses that are permitted. You saw that in the bytecode, right? So they just gave you API to pull that in and give it to you so you can use that as well. And not only that, the last thing I want to mention here is you can use this in pattern matching as well. So when you're using pattern matching, if you use a sealed class, it is going to help you with knowing that all different options are being met. So as a result, when you compile your code, it's going to say you don't need to write a default, because your closed hierarchy, you have covered all the options. As a result, you don't have to worry about putting a default option. If you're curious more about it, I am giving an entire talk only on patterns. I don't remember which day I'm giving it. I don't think it's today, but in the next 2 days, I'm giving a talk on patterns. So if you're interested, you can come to that one. And of course, you can pretty much rely on that. And of course, what if you add another type later on? What are you going to do about it? And the answer to that question is they take care of it by throwing an exception if the object that comes in is not the type they expected. So it's better to leave out the default. Like I said, I'll go into more details in pattern matching than here. I just wanted to allude to it. So to summarize what we talked about, this is a feature that solves one specific problem. It's a nice solution for that problem, but you need to make sure that when you use it, you really have that problem to solve. So play with it, but also use your common sense to determine what options make sense. If you see developers just throwing around things like non-sealed, that doesn't really make sense. So you need to be very careful how you use it as well. But the beauty is you don't have to write a lot of code. The compiler takes care of that for you. And you've been such a great group. So thanks for all that questions and interactions. Thank you so much. That's all I have.